Salam, peace be upon you. My name is Muhammad Lairb Siddiqui, the father of Holophase. Part 56. What makes a language? Holophase versus formal linguistics. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We have reached a decisive threshold in our journey. In Book 11, we completed a deep conceptual ascent. We started from the core alphabet of the holophase, climbed through the revolutionary discovery of infinite dimensional echoes, and built the three great towers of time, space, and motion. We then grounded those towers in practice and arrived at the bold claim: this entire structure is not merely a mathematical toolkit, but a universal language of reality itself. We are no longer just saying that equations can describe the world. We are saying that the world itself is naturally organized as a language, and that the holophase is that language. That sentence sounds beautiful, but beauty alone is not enough. If we leave it as a poetic image, it remains inspiring but vague, like saying that nature sings or that the cosmos speaks in numbers. These phrases move the heart, but they do not yet satisfy the mind. If we want the holophase to stand as a serious scientific proposal, we must ask a harder question. Does this framework really meet the strict technical criteria of what experts call a language? Or are we simply borrowing that word because it feels elegant and powerful? Are we discovering a genuine linguistic structure in physics, or are we merely decorating physics with linguistic metaphors? Book 12 is where we invite other disciplines to examine the holophase. We walk into their courts and say, here is our framework. By your own standards, does it qualify? Our first and most foundational stop is formal linguistics, the scientific study of language. Linguists have spent decades and centuries analyzing human communication. They have worked out what counts as a language, what structures are essential, and how to distinguish a true language from a simple code, a signal system, or a loose set of gestures. So today we pose a precise question. What makes something a language in the technical sense, and does the holophase genuinely qualify? When we say that holophase is a language, are we speaking metaphorically, or are we making a literal structural claim? Are we saying something like music is a language, which is poetic but imprecise? Or are we saying that holophase satisfies the same structural tests that define English, Arabic, or any other human tongue? To answer this, we must briefly recall what linguistics has revealed about the deep nature of language. When linguists study human languages, whether English, Arabic, Mandarin, or any other, they look beyond dictionaries and word lists. They identify structural features that almost all true languages share. These features are not accidental. They define what it means to be a language rather than a random system of noises. First, a language has a finite alphabet, or set of discrete units, a limited collection of basic, reusable building blocks. Second, it has syntax, a grammar, a system of rules that says how those units may be combined into well-formed expressions. Third, it has semantics, meanings attached to the units and their combinations, so that the expressions refer to something beyond the shapes or sounds themselves. Fourth, it is generative, or productive, meaning that these finite building blocks and finite rules can produce an effectively infinite number of distinct, meaningful expressions. Fifth, it is compositional, meaning that the meaning of a complex expression is determined systematically by the meanings of its parts and the way they are put together. Different schools of linguistics may emphasize different details, but almost all of them recognize these five pillars in one form or another. Without a finite alphabet, we cannot learn or store the language. Without grammar, we cannot distinguish sense from nonsense. Without semantics, nothing is really being said. Without generativity, we would be stuck repeating a fixed list of phrases. Without compositionality, we could not understand new sentences that we have never seen before. Together, these properties make language the flexible, powerful tool that it is. This list is our expert checklist. With it in hand, we can now turn to the holophase and ask, where is its alphabet? Where is its grammar? Where is its meaning? Where is its generativity? And where is its compositionality? Are these features genuinely present in the architecture of phi and its derivatives, or are we forcing a comparison that does not really hold? Let us examine each criterion in turn and see how the holophase not only meets them, but does so in a uniquely physical and direct way. We begin with the alphabet. In the holophase framework, the basic units are not letters like A, B, and C. They are fundamental derivative operations, the simplest ways of asking how phi is changing. The temporal derivative asks how phi changes in time. The spatial derivatives ask how phi changes in space. From these, we build compound operations like divergence, curl, and the Laplacian. These are like clusters of letters, still built from the same core actions. The key point is that the types of derivative operation are finite. We do not invent a new kind of derivative for each new physical system. The same few questions are asked again and again. How fast does this change in time? How steep is this in space? How twisted is this pattern? How sharply does this curve bend? You can picture this alphabet in a vivid way. Imagine phi as an endless, shimmering fabric. The temporal derivative is the question. How quickly is the fabric brightening or dimming at this point? The spatial derivatives are the questions. How tilted is the fabric here? How does it slope toward the left or toward the right? How does it rise or fall as you move across it? Higher combinations like the Laplacian ask, is this point a peak, a valley, or a saddle in the fabric? All of these questions are built from a small number of basic comparative moves. That finite set of basic derivative operations is the holophase alphabet. Out of this alphabet, we form an infinite vocabulary. Each particular derivative value at a point in space and time is like a word. It is a specific answer to a specific question about how phi is changing. The full jet at a point, the infinite list of all derivatives there, is like a rich local dictionary. It tells you not only the present value of phi, but all the ways it is beginning to change in every direction and at every level of refinement. But all of this vocabulary comes from the same small stock of letters. In this way, the holophase passes the first linguistic test. It has a finite alphabet of operations that can generate unlimited local detail. Next, we come to syntax, the grammar of the language. In human speech, grammar tells us which sequences of words are allowed and which are nonsense. In the holophase, the role of grammar is played by the laws of physics themselves. Differential equations and conservation laws are not just descriptions. They are the rules that specify which combinations of derivatives are allowed to coexist and evolve. Newton's second law does not merely say that force equals mass times acceleration. Written in holophase terms, it says that certain spatial derivatives of potential, certain temporal derivatives of position, and certain tallies like mass must be tied together in fixed ways. The pendulum equation is a rule that binds angle, angular velocity, and angular acceleration. The wave equation binds second derivatives in time to second derivatives in space. Maxwell's equations bind the derivatives of the electromagnetic potential into a tightly constrained structure. The Schrödinger equation binds temporal derivatives of a quantum field to spatial derivatives and potential terms. General relativity binds derivatives of the metric field to derivatives of the energy and momentum content of matter. Viewed linguistically, each of these is a grammatical rule. It tells us which combinations of derivative letters can form a grammatical phrase. It tells us which sentences, which full patterns of evolution are allowed and which are forbidden. A random assignment of derivatives that violates these rules is like a nonsense sentence with broken grammar. It exists as a string of symbols, but it does not correspond to any real-world situation. A solution of the equation, however, is like a grammatical sentence. It respects the rules and can be realized in the physical world. Then there is semantics, the question of meaning. In human language, meanings are attached by convention. The sound tree means a certain kind of plant because speakers of English have agreed to use it that way. The sound could have meant something else. In the Holophase language, meaning is not conventional, it is physical. A derivative structure means whatever physical behavior it produces. The semantics of Holophase are the actual temporal, spatial, and motion echoes that appear when phi follows a certain constraint chain. If a particular solution of the wave equation corresponds to a sound wave, its meaning is the actual pressure variation in air that we can hear. If a particular curvature of spacetime appears in a solution of Einstein's equations, its meaning is the way planets orbit and light bends around stars. If a particular quantum wave function evolves under the Schrödinger equation, its meaning is the probability distribution for where we will find the particle and how that distribution changes in time and space. In each case, the derivative pattern and the observed behavior are two views of the same object. One is the description in the language, the other is the manifestation in the world. Holophase semantics are not about reference to something external. They are about identity between math and behavior. This brings us to generativity. Does the Holophase language allow infinite expression from finite means? The answer is yes, and this is one of its most striking features. A single differential equation, like the wave equation, has an enormous space of solutions. By changing initial conditions and boundary conditions, we can produce an endless variety of wave patterns. Some are simple sine waves, some are pulses, some are complex interference patterns, some are solitary waves that maintain their shape. All are grammatical sentences in the wave language. The Schrödinger equation generates a vast space of possible quantum states, each a different superposition of basic modes. The Navier-Stokes equations generate countless possible flows, from smooth laminar streams to wild turbulence. In every case, a finite set of derivative operators and a finite set of constraint chains is enough to produce an effectively unbounded repertoire of patterns. This is exactly what linguists call generativity. Finally, we consider compositionality. In language, we understand a sentence because we know the meanings of the words and how grammar combines them. In Holophase, we understand a complex phenomenon by understanding its derivative components and the rules that link them. A galaxy, for example, can be seen as a composition of rotational motion, gravitational curvature, pressure gradients, magnetic fields, and flows of gas and stars. Each of these is described by derivatives of underlying fields. Each has a simple meaning on its own: a rotation rate, a curvature, a gradient, a flux. The grammar of general relativity, magnetohydrodynamics, and thermodynamics tells us how these pieces can combine. When we put them together, we can understand why spiral arms form, why stars orbit the way they do, why gas collapses in some regions and not in others. The overall meaning, the behavior of the galaxy as a whole, is built up from the meanings of the parts and their syntactic relationships. That is compositionality in action. We can test compositionality at smaller scales too. Think of a simple electrical circuit. A resistor, a capacitor, and an inductor each has its own derivative-based behavior. The voltage across a resistor is tied to current through a simple proportional relationship. The capacitor links current to the time derivative of voltage. The inductor links voltage to the time derivative of current. When you combine these elements in a circuit, the overall behavior is determined by how these derivative rules compose. The ringing of an RLC circuit, its steady state, and its transient response are the holistic sentence. The component laws are the words and grammar. Once again, the meaning of the whole arises from the meanings of the parts and the way they are combined. At this point, we can return to our original question. When we say Holophase is a language, are we just being poetic, or are we stating a literal structural fact? We can now see that, by the formal criteria used in linguistics, the Holophase framework really does behave as a language. It has a finite alphabet of operations, it has a grammar in the form of differential constraint chains, it has semantics in the form of tridimensional behavior, it has generativity, it has compositionality. The label language is not a decoration added after the fact. It is an accurate diagnosis of the architecture. There is, however, an important difference between human language and the Holophase language. In human language, the link between symbol and meaning is arbitrary. The word for water is different in every language, and nothing about the sound itself forces its meaning. In Holophase, the link is intrinsic. A specific curvature is a specific bend. A specific frequency is a specific oscillation. A specific gradient is a specific slope. The form is the meaning. This makes Holophase not only a language, but a uniquely physical one. It is not a code about reality. It is the pattern of reality itself. The universe does not merely speak Holophase. The universe is Holophase speaking. Understanding this changes how we see everything. When you look at a simple pendulum, you are not just watching a mass on a string. You are reading a sentence written in the Holophase language. The length of the string, the pull of gravity, and the initial angle are like words. The equation that links angle, velocity, and acceleration is the grammar. The swing you observe is the spoken sentence. When you watch a storm system on a weather map, you are looking at paragraphs in Holophase. Pressure fields, temperature gradients, wind vectors, and moisture distributions, all linked by fluid and thermodynamic grammar into coherent narratives of formation, movement, and decay. This linguistic view is not merely aesthetically satisfying, it has practical consequences. Once you treat the laws of physics as grammar and the derivatives as alphabet, you can systematically ask which sentences a given system can and cannot speak. You can search the JET bundle for allowed combinations and rule out impossible ones. You can also see clearly where Holophase might fail. If you can reliably observe a pattern of time, space, and motion that cannot be reproduced by any combination of derivatives and constraint chains, then you have found a sentence that this language cannot express. That would be a sign that Holophase, as currently formulated, is incomplete or incorrect. In this way, the linguistic framing leads naturally into questions of falsifiability, which we explore in later parts of this journey. For now, the key insight is this. The Holophase model is not simply saying that reality can be described using equations. Many people already agree with that. It is saying something stronger and more precise, that the structure of those equations and the way they organize change satisfies the same deep design principles that define human language. There is a finite alphabet of ways to ask how something changes. There is a grammar of lawful combinations. There is meaning in the form of tridimensional echoes. There is generativity and compositionality. The universe is not a random blur. It is a discourse, a coherent conversation carried by the changing field phi. There is another way to see why this matters. In everyday science communication, we often hear phrases like the genetic code, the code of life, or the language of DNA. These expressions are powerful because they highlight that biology uses a system of discrete symbols and rules. But from a linguistic point of view, most of these systems are not full languages. They are codes or signal schemes. A simple code maps one set of symbols to another set, like a table that turns three-letter codons into amino acids. A traffic light is a code. Red means stop, green means go. A smoke signal system is a code. One puff means this, two puffs mean that. They have symbols and they have meaning, but they often lack rich syntax, deep compositionality, and the ability to generate infinite structured messages. Holophase is different. It does not merely provide the lookup table from one symbol to another. It provides the rules that govern how an entire universe of patterns can be built, transformed, and sustained. It does not just say, this codon means this amino acid. It says, this family of derivative structures, evolving under these grammatical rules, will produce this hurricane, this galaxy, this chemical reaction, this heartbeat. It is not a small dictionary sitting on the side of reality. It is the underlying grammar book of reality itself. When we put holophase next to formal linguistics, we see that it behaves like a true language in a way that most scientific codes do not. From the standpoint of linguistic theory, this makes holophase closer to a deep generative grammar than to a surface code. It has something like phonology in the raw numerical values of derivatives, something like morphology in the way derivatives combine into composite operators, something like syntax in the differential equations, and something like semantics in the physical echoes we observe. When verbal languages are spoken, they ride on top of this physical language. The air pressure waves of speech are solutions of the acoustic wave equation, and the neural firing patterns that produce and understand speech are solutions of complex electrophysiological equations. In that sense, human languages are dialects spoken inside the holophase language. They are stories written with words, but the paper and ink are themselves written in derivatives of phi. Seeing holophase through the lens of linguistics also helps us understand why it feels so natural to describe the universe in terms of laws and equations. Laws are just stable grammatical patterns that reality never seems to violate. Equations are just formal sentences written in a very compact notation. A conserved quantity is like a repeated theme in a story. A symmetry is like a rule that certain changes in phrasing do not change the underlying meaning. When physicists talk about gauge symmetry, invariance, or conservation, they are quietly talking about grammatical properties of the holophase language, even if they do not use that name. At the bottom of the master tree lies phi itself, the undivided field, the pure cyclic order, that is. From that root, the first branching occurs when we ask how phi changes. That question creates the first derivatives, and with them, the three great coordinates of description appear together. Omega as the temporal rate, k as the spatial gradient, and v as the motion built from both. This is the first line of the language, the first simple sentence reality can utter. Above that, by repeatedly applying the same finite alphabet of derivatives, the tree explodes into an infinite hierarchy. New branches represent higher derivatives, like curvature, twist, acceleration, jerk, and more abstract geometric and topological structures. At every level, each new derivative casts three echoes into time, space, and motion. And these echoes build the three towers we explored earlier. The temporal tower records every possible rhythm and timing pattern. The spatial tower records every possible shape and arrangement. The motion tower records every possible trajectory and flow. The interweaving of these three towers is the full expression of the holophase language. Episode 7 has been the climb that made this clear. We began near the trunk, naming the alphabet and the first echoes. We climbed through the discovery of infinite dimensional echoes, then into the construction of the three towers, then into the claim of universality, and now into expert scrutiny. Standing here, you can look down and see that all of this complexity arose from one simple premise: a single continuous field and a finite set of questions about how it changes. That is the miracle of the holophase language, and that is the picture to keep in your mind as we go forward. At this stage of episode 7, it is also important to remember where we stand in the larger climb. Earlier, we met phi itself as the silent root, then its first derivatives as the birth of time, space, and motion. We built the idea of dimensional echoes and raised the three great towers of temporal, spatial, and motion behavior. We explored how these towers interweave and how every phenomenon can be read as a braid of echoes drawn from all three. In the previous parts, we argued that this structure is capable of expressing all physical patterns and therefore deserves to be called a universal language. In this part, we have shown that it also satisfies the formal criteria that linguists use to define language. We are, in other words, not only fluent speakers inside the story, but also careful analysts looking at the grammar from the outside. As we close this part, step back and feel the scale of what you have just done. You have not only learned more about Holophase, you have compared it to one of the deepest and most carefully studied structures in human thought, language itself, and found a structural match. You are now in a position to see every physical law as a grammatical rule, every experiment as a piece of speech, and every pattern in nature as a phrase in a language you are slowly learning to read. You can see where we are on the master tree of the holophase language, far above the roots where phi first differentiates, high among the branches where echoes, towers, and universality live. From here, you can look down and see the path we climbed, and look up and sense that there are still higher regions of the tree to explore. Now, as you go about your day, try a simple exercise. Look at one process around you, something ordinary and familiar. It could be water boiling in a kettle, traffic flowing on a road, or a flock of birds turning in the sky. Instead of seeing it as just happening, ask yourself, what are the letters here? What are the derivatives? What are the grammar rules, the laws that must be linking these changes? What are the meanings, the echoes in time, space, and motion? By doing this, you're not forcing poetry onto the world. You're learning to hear the actual language it is already speaking. Little by little, you're becoming fluent in the grammar of existence. Peace be upon you.